How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some practice problems for chirality. So which one of the following molecules is chiral? So when we're dealing with like carbon specifically, how you know if a carbon will be chiral is if there's 1, 2, 3, 4 different substituent groups on it. If 2 of those are the same, you can't have a chiral molecule, right? Remember, chirality has to do with non-superimposable mirror images. So for carbon, with it being able to make 4 bonds, you need 4 different substituent groups. So which one of these is chiral? Well, it ain't going to be A. It ain't going to be B. Let's see. Ain't going to be C, because let's see. This carbon has 1, 2, 3 identical groups. This one has 2 identical groups, so it can't be that one. Ooh, what's going on with this carbon? That carbon right there is connected to a carbon that's got 3 fluorines. So that this carbon definitely not chiral. But what about this one? We have a chlorine, we have a bromine, and what else is there? It must be a hydrogen. So if you count them, we got 1, 2, 3, 4 different substituent groups. So choice D will be chiral, and then choice E definitely not. All right. Number 2, how many chiral carbon atoms are there in 2,2-dimethylpropane? So let's draw it out. I got propane, so C, 3 carbons. 2,2-dimethyl tells me that on this second carbon there are 2 methyl groups. And let's see, all of those missing bonds are to hydrogen. So how many carbons are chiral? None of them. None of those carbons are chiral, because the center carbon has 4 identical substituent groups, and then the other carbons have 3 identical substituent groups. So it's none of them are chiral. Number 3, how many chiral centers are there in this molecule? So again, draw it out, right? This is the condensed structural formula. Draw it out. CH3 bonded to a CH2, which is not going to be chiral because of the CH2. CH3, definitely not chiral. Bonded to a CHCl. Possibly. Let's see what else we got going on. Bonded to a CH2, bonded to a CH2, bonded to a CHBr, bonded to a CH3. So definitely not chiral, definitely not chiral, definitely not, definitely not, because it's got more than 1 hydrogen. But let's take a look at this carbon. So on this carbon, we have a hydrogen, we have a chlorine, we have a 2 carbon group, and we have a 4 carbon group over there. So this is definitely 1 chiral center. Let's take a look at this carbon that's got the bromine on it. Looks like the same kind of things going on. It's got a hydrogen, it's got a 1 carbon, it's got a bromine, and it's got like a, 5 carbon group. So this is a second one. So there are 2 chiral centers in that molecule. 4, what are enantiomers? All right, so we've been talking about them this whole time, right? They're non-superimposable. Mirror images. Right, so I'm thinking left shoe versus right shoe. Are they mirror images? They sure are. Can you superimpose them so they are exactly the same? No, you can't. Right, you got a left shoe, you got a right shoe. Right, so that is what an enantiomer is. All right, so I hope you found that helpful. I'll see you in class. Okay, bye.